Let's take a look at this problem out of 6.2. It's asking us to find the area of the region described below, and it's saying the region is bounded by the exponential function e to the x, e to the negative x, and the vertical line y equals the natural log of 6. So I didn't need to consult my graphing calculator because we don't really need to know the exact it would be the approximate intersection points of these for the y values. We just needed to know the x values. Now we know every single exponential function crosses through the point 0, 1 as long as it's not being vertically shifted. So I went ahead and drew in the light kind of green teal function. That's my y equals e to the x. I knew any negative exponential function just meant it's reflected about the y-axis, so my y equals e to the negative 3x is my red function here. It probably goes up more quickly than how I graphed it, but that's not relevant to what we need here. Now, it also wanted us to draw the vertical line at x equals the natural log of 6, which is approximately 1.75. So I drew my vertical line in there. So the region bounded, I went ahead and shaded here with yellow. That's the region that we're finding here. Now, I only needed to know the x values because clearly there's a top function and a bottom function. So whenever I would be finding the area of this region, all I would have to do is go in there and say, well, what we're doing is we're going to find infinitely many little rectangles in there, and the width of each rectangle is going to be a change with respect to the x-axis. That's why we're going to integrate with respect to x. The rectangles would begin when x is 0. They're going to end when x is the natural log of 6. That's why my area here is the integral from 0 to 6. The height of each rectangle would be the top minus the bottom. Y equals e to the x minus y equals e to the negative 3x, integrated with respect to x. Those integrate pretty easily. We know that the integral of any exponential function is that exponential function. Now in the second one, you have to remember the chain rule. Yes, the integral of minus e to the negative 3x would be minus e to the negative 3x, but then you would divide by the derivative of the linear function on the inside. So you divide by negative 3. That's why I changed the minus sign to a plus here and just divided by 3. So we've integrated correctly here, and now we need to evaluate from 0 to the natural log of 6. When I evaluated this first one, we know that e to the natural log of 6, e and natural log just cancel each other out, and you're left with the 6 for that. Similar, in the second one, that e to the negative 3x, remember that's the same thing as e to the x raised to the negative third power. So that's what I did. I said, well, if I plug a natural log of 6 into that, it's going to be e to the natural log of 6, which will give me a 6, but then I need to raise that to the negative third power. That's what I've done here. So now I can say, all right, plus 6 raised to the negative third power, all divided by 3, that's the upper limit. The lower limit, we know any number raised to the 0 power is going to be 1. So we'll have 1 plus 1/3. So I had 1 plus 1/3 there. That gives me a total of 4/3. I know 6 is the same thing as 18/3. 18/3 minus 4/3 gave me my 14/3 for my top part. And then this next part, 6 to the negative third power, this is the same thing as 1 over 6 cubed. 6 cubed is 216. 216 times 3 in the denominator would give me a 648. I, of course, had to use my calculator to add these two. 14 over 3 plus 1 over 648. It's going to give me 3,025 over 648 for our final answer. I like that problem a lot.